Example 3. Here we have 3 ropes again holding up a weight, but this problem doesn't have symmetry. The 2 ropes are tied to the ceiling at different angles. But we have our point of concurrency, point A. I'm going to draw the free body diagram. We have a 50 Newton force straight down. We'll just call that T1 for now, though. The rope's pulling straight down. And then we're going to have, I'm going to call that one T3. And this one here, T2. But once again, T2 and T3 are at angles, so we'll need to figure out their components, but I'll draw the diagram first and then figure out the components. But T1, straight down, I will put that in there now, it's 50 newtons. And then we have T3x and T3y. And then we have T2, which is pulling to the left on that point. T3x. Sorry, it's T2x. That's T2x. And T2y. Alright. So, actually, before I go much further, what you're going to see here, we got a little bit more of a difficult problem than the last one because in the last problem we had symmetry. So the two upward, the T2y and the T3y would each be 25 newtons if you had symmetry. But all we know in this case is that T2y plus T3y equals 50. And they're not equal because of the different angles. We also know, or can write at least, T2x equals T3x. I'm going to just box those up right now and come back to them because basically we have 4 unknowns right now. Now let me go to the vector component diagrams. I'll do those over here to the left. And T2, that's T2. T2 has a leftward component and an upward component. T2y, T2x. And my diagram is not real good as far as scale, but that lower right hand angle right here is 50. That's alternate interior with the one that is in a diagram. And once again, if you do sines and cosines, I'm going to skip all the small steps, but doing the same steps for components that we've done several times, it turns out that T2x equals T2 times the cosine of that 50-degree angle. And I'll let you skip these steps. You can, on your own homework, you can just do it this way. Or you can write in the extra steps that get you here. But T2y equals T2 sine 50. You can already see this problem is going to be a little bit more symbolic than we're used to. We've done a few problems like this, but these 2 values are important. We can't do much more with them right now. We will in a second. But the same thing with T3. T3, right, has 2 components. It has T3x, that's T3, and T3y. Once again, by similar work, and geometry, that's 30-degree angle. And if you know your 30, 60, 90 triangles, you could take some shortcuts as well, but I'm not going to do that right now. But using sines and cosines, T3x comes out to be T3 times the cosine of 30 degrees, and T3y is going to be T3 sine of 30 degrees. Alright, so if you look at the 3 boxes I have here, if you look inside and count them all up carefully, basically what you have are 6 equations and 6 variables. So in general, in math and algebra, this is solvable. You need 6 equations to solve 6 unknowns. Basically, it's just going to be massive substitution. All the physics is now done. Massive, massive substitution. So what I'm going to do is take these quantities and plug them in there, and these quantities and plug them in there, and get some what are going to look like beastly equations. For example, the top equation, it says T2y plus T3y T sub 3y equals 50 becomes T2 sine 50 plus, and I got that from right down here. I'll circle it in blue, way down here on the left, because T2y is T2 sine 50. That's what I subbed in right there. And T3y, I'll sub this in right now, is T3 sine 30. So plus T sub 3 sine 30 equals 50. I'll do the next substitution in black. So what I'm going to do now is set the two T2, the x components equal. In other words, I'll circle over here on the left. That value will be equal to this value, because that's the T2x and the T3x. So therefore, T2 cosine 50 equals T sub 3 cosine 30. All right, if I take this second equation, the one in black here, solve for T2, I get T2 equals T sub 3 cosine 30 degrees divided by cosine of 50 degrees. Now, I'm going to sub that into the blue equation. So I'm going to take this value right here, that big guy, and plug it in right there for T sub 2. And I'm going to move down the page here, and we get a pretty large equation. So when I do the substitution here, I end up with T sub 3 cosine of 30 all over cosine of 50. That's the part I'm plugging in. That's the big substitution. Times the sine of 50, which was still there, plus T3 sine of 30 equals 50. So that's bringing this blue equation from the top down to here with that one big massive substitution. Now what I'm going to do right now is actually evaluate all these sines and cosines, because those all have decimal approximations. You can figure those out in your calculator. I'm going to do that off to the side and give you the result. So I evaluated those. I plugged in the cosine of 30, and I divided it by the cosine of 50, and I multiplied by the sine of 50, and that comes out to be 1.03 times T sub 3. And then the sine of 30 is 0.5 times T sub 3 equals 50. Now this is pretty easy to solve at this point, because you have 1.53 T sub 3 equals 50. Voila! T sub 3 is 33 newtons. All right, and we already knew that T sub 1 was 50 newtons, so we're 2/3 of the way done, but actually we've done all the hard algebra, because once you know what T sub 3 is, you can take this equation up here on the right, and let me just go back to red, right up in here, up on the right, I'm circling in red. I'm going to bring that down over here to get my T sub 2. My T sub 2 will be your T sub 3, which we now found was 33, times the cosine of 30, times the cosine of 30, divided by the cosine of 50. That was just bringing down that value for that equation in the black up there in the upper right. So if you just plug that all in, you end up with T sub 2 equal to 44 newtons. So thanks for hanging in there. Congratulations. We'll see you in class.